We are in dear today once again Bagbul Islam to learn about the MCQs for the new chapter vector. We start from the question number one, first MCQs for any vectors A and B, then A plus BS equal to A minus A plus B A plus minus B and C A plus B and D B vector minus A vector. So this is very simple question for E vector A and B. Then A vector minus B vector is equal to. So we can write this system according to the property. If we expand this one A plus minus B, so the results will be equal to A vectors plus into minus B. Open the bracket, so the result will be minus B. So the correct answer is B. The unit vector for along x-axis is so the definition of unit vector. First of all, we define the what is unit vector. Unit vector has the magnitude is only one. Those type of vector, if we take the magnitude, so the result will be equal to 1. So it is called unit vector. But here in the direction is along x-axis. Along x-axis, this is y and this three-dimensional space. Along x-axis, y-axis, and z-axis. So along x-axis means that so the first this one is correct. If we change the question here, the same, the unit vector for along y-axis is, so then the answer will be in this situation we will get here A will be the correct answer for the unit vector along z-axis will be dash So the correct answer will along direction of the unit vector is along x-axis. Unit vector means, for example, u is any vector whose magnitude is 1. That is called unit vector. We take the definition of u head is equal to given vector direction in whose magnitude is 1. So if we want to take the magnitude of this one, so the magnitude will be equal to of both one. So whose magnitude is equal to 1. So there will be u magnitude and u magnitude. Both are cancelled to each other. Whose magnitude is 1. That is called unit vector. But in this question, the direction is along x-axis. That is along, y-axis, z-axis. So x-axis, I, J, and K. So in this direction, z-axis, so we can write the correct answer is C, along the direction, because we can write the unit vector u is equal to 0i plus 0j and plus 1k. So zk is along z-axis. If we take the magnitude of this one, so the result will be equal to 1. So for this reason, we can write here u magnitude 0 square plus 0 square plus 1 square. So the result will be equal to 1 square. So both are cancelled. So the result is 1. So that is called unit vector. F A is equal to I and B is equal to J and C vector is equal to K, then A dot B cross C is equal to, what is the answer? 0, B, 1, C is equal to -1 and D is equal to 2. Look here, if we are applying A dot B cross C, first of all we find the value of B cross C. So the result will be equal to, according to this definition, if we are applying I, J and K. Here B cross C. B cross C we get I. B cross C, the direction of anti-clockwise. So J cross Ki is equal to I. And this situation, if we are finding A dot B cross C, so B cross C we can find here A dot, we get A, and here A dot A is equal to 1. So the correct answer will be equal to B. If the coordinates of 2 points P 3 and Q is equal to -1, 2 and 4, are respectively, then PQR will be equal to, what is the answer? 3 was 7, B 1 was 7, and C 4 was 8, and D is equal to -3, -3, -7. 2 points are given. If we are applying here this property PQ, we can write OQ minus OP, we can write. So, and here minus 1, 2, and 4, minus 2, 1, minus 3. If we subtract this result, minus 1 and minus 2, 2, minus 1, and 4, minus minus plus 3. So we get the result minus 3 and 1 and 7. So the correct answer will be equal to B. So these are the position vectors. According to the definition of position vector, we have the coordinates of on the x-axis in three axes are 0, x was 0, x 0, 0, and c minus x 0, 0, and a 0, 0, and x. So three dimensional space are given here. This in three axes in jk, x, and y, and z. So along x-axis, the three coordinates of the system of the point is given along x-axis in the three-dimensional space. So along x-axis, so this result will be correct. And here the coordinates of a point on the along y-axis in the three-dimensional space. So the definition is here changed. For example, we write here 0 and y and 0. So in this situation, the correct answer will be equal to C. C is the correct answer. And so the same MCQs, if we change the coordinates of a point on the z-axis in the three-dimension axis are, so here we write z, then will be correct answer along D is the correct answer in this situation. There are possibilities in the coordinate system. And the position vector of the point P is y-axis, and these are the points. Is how we can write OP, OP magnitude, and the P magnitude. The position vector is always started from the initial point at the origin, and his division VARs are implied. Obey this rule. OP is any point which is started from the position vector x-axis and y-axis. So this is the position vector. P is any point x, y, and z. So this is the position vector if we write geometrically OP. Question number 10. If two vectors A and B A dot B is equal to 0, then the vectors are parallel, perpendicular, tangent, and none of these. This is clear definition of if two vectors, if they are perpendicular, they are dot product or scalar product are 0. That is given the condition. Given condition is given that dot product. Dot product means they are scalar product. Scalar product if two vectors A dot B both are perpendicular and they are dot product or scalar product is 0. So the lines two vector are perpendicular. They are perpendicular. If we are want to prove that formula according to the formula, so we are applying here A dot B magnitude, A magnitude, B magnitude, and cos theta and cos theta cos 90 is perpendicular. If we put here A magnitude and B magnitude, cos 90 is equal to 0. So this will be 0. That means that A dot B is equal to 0. So the both lines or both vectors are perpendicular to each other. Thank you very much for watching. Please subscribe my channel.